Here in the National Analysis Center of the Deutsche Bundesbank, the German national bank with its over 10,000 employees, we identified and processed approximately 140,000 counterfeit euro coins and about 900 precious metal coins and bars last year. For the detection of counterfeit coins, we have a variety of methods and testing devices at our disposal, in addition to optical examination. With these devices, we can determine the density of the coins, conduct a chemical analysis of the surface, and examine the electrical conductivity of the metal. Thus, the National Analysis Center supports the banks and the police in the fight against the trade with counterfeit gold coins.
Yeah, talking about gold in Germany does not only mean talking about Bundesbank's 3,351 tons of gold. No, we also have to talk about the 9,000 tons which are privately owned in Germany. And due to the fact that gold, especially coins and bullions, are of great interest among German investors, we, as a result, are confronted with a rising number of counterfeits. Therefore, I considered it might be worthwhile to give you, hopefully, an interesting inside view into the dark world of counterfeit gold coins. Yeah, here's the agenda of what we are going to talk about the next couple of minutes. Methods of analysis. We go through the types of counterfeit gold coins. We will have a detailed view on the counterfeit gold coins with a tungsten core. And finally, we will discuss some conclusions. Yeah, where do I come from? I come from the National Analysis Center of the Deutsche Bundesbank. We are engaged in scrutinizing counterfeit banknotes and coins, and we classify counterfeits. This means we try to assign counterfeits to potential counterfeiters. Collaborating with law enforcement authorities is also one of our topics. And the last rolling year, we encountered roughly 140,000 counterfeit euro coins here in Germany, compared to approximately 880 counterfeit precious metal coins and bars. And of course, the value or the damage caused by these 880 coins and bars is much greater than that of the euro coins counterfeited. Yeah, here is a counterfeit euro coin. Yeah, before we come to the coins, I would like to make a little detour through the bullions, since bullions are not an official means of payment in Germany. We do this as a kind of administrative assistance for our law enforcement authorities. Yeah, here you see typical bullions, nicely sealed with an identification number. It all looks pretty genuine, but they are counterfeit. And they don't appear just one or two. No, they appear in larger quantities. And in many cases, the police is sitting next to me and saying, well, we caught somebody with a smoking gun and want to have a quick response. Are they counterfeit or not? Yeah, and we'll show you later, or I will show you later, how we handle this. It's not only one specific manufacturer permit. No, we have all kinds of gold bars in our program, or they'll come to us. Yeah. And one means of detection is the thickness. So gold has a high density. In order to imitate gold, you need a higher thickness. So the counterfeits made out of brass, they have a much higher thickness than those made out of gold. Yeah, we also have interesting Doré bars from the Customs Frankfurt Airport. They just want to have an overview what's inside. Here, most likely iron is inside, but beside iron, we have the entire periodic table of elements. Yeah, and of course, coins, coins, coins. That's what we are confronted with. And with this picture, I would now come to the methods of analysis. How do we analyze coins? Counterfeit gold coins or coins in the National Analysis Center here at Deutsche Bundesbank. My favorite is still the microscope. It's an easy detection of minting defects such as depression, raised lines or points. whatever on the coin. I have a very quick overview on the edge lettering, which is very important for certain coins, especially ancient German gold marks. And of course, it's an easy comparison between the minting quality of a genuine coin and a potential counterfeit. Yeah, the first step, which is mandatory in our procedures, is the measuring of the specific gravity or the density. It follows the Archimedes principle. And what do? We measure the coin on air, and then we measure the coin in water. And due to the fact that the coin displaces the water, it receives an upward-driven force, so-called buoyancy, and the coin gets lighter. And due to the fact that the density of water is 1, the difference in weight represents the volume. That's the trick behind it. And this all is calculated in this nice scale. So what is the advantage of the measurement of the specific gravity? You can measure even complex structures, and it's an integral measurement. You measure the entire body. You get an answer about the composition of the entire body. It's a simple detection of poor counterfeits made out of steel. Steel has a density of 7.8. Brass, roughly about 8.8, 8.9, zinc, lead, etc. And of course, we do an approximation of the gold content by comparing the density of the existing coin and existing alloys we have. Here is a little example of how it works. We measure the coin on air. This is a Mexican peso, and we measure a weight difference in the water. And finally, we calculate the density, or the machine calculates the density for us, and we come to 7.1 gram per cubic centimeter, which is a pretty high density. The second step is the measuring of the chemical analysis. We do this with an XRF, a German tongue twister. It's X-ray fluorescence spectroscopy. Yeah, I would like to say this. And how does it work? We fire an X-ray from this handheld device. It's the size of a hairdryer. We fire this X-ray into the coin, and the X-ray interacts with the atoms of the alloy, mainly with the inner electrons, and finally gives a response with respect to the amount of alloy content, the chemical composition, amount and quality, what's inside. It has a high flexibility, it delivers a good overview, but you have to be very careful. The X-ray XRF has just a penetration depth of 0.05 millimeter. And it covers just a very small area of just 1 square centimeter. So using this, it requires a certain amount of knowledge or way of interpretation. Another step we apply is the measuring of the electric conductivity. The electric conductivity, we don't use high voltage and we don't need a new colleague every week. No, it's a very elegant way. We measure with a high electromagnetic field. We put the sensor on the coin, and the high electromagnetic field penetrates into the coin, generates so-called eddy currents, and these eddy currents, they have an electromagnetic field which later on influence the sensor, and with this we can measure the conductivity of the metal. And the theory behind it is that each metal or each alloy has its specific electric conductivity. So we can assign the electric conductivity to a certain metal or to a certain alloy. And of course, it's a very quick measurement. It penetrates into the specimen, and the penetration depth can be varied by the frequency. It's an anti-proportional relation, so 100 Hertz comes to 12 millimeter penetration depths, whereas 120 kilohertz just goes up to 0.4 millimeters. And measurement through plastic foil is absolutely no problem. It's possible. You have seen all these bullions all sealed, so we can measure it very quickly by using this device. And bullions and coins can be tested with a seal unbroken. So this is also very important. And typical unit for electric conductivity is mega Siemens. We are here in Siemens City in Berlin, mega Siemens per meter. And another one is percent IACS. This is International Annealed Copper Standard. What you have to take into account, we have very careful, it's the typical electric conductivities. Looking at fine gold 4.9, you have 44 mega Siemens per meter, whereas the Krügerrand with a slightly lower gold content, you just have 9.7 mega Siemens per meter. So this is not a linear relation, it's an exponential relation. So slight impurities have a significant influence on the electric conductivity. And finally, we use a projector. It's mainly used for the quality inspection of our euro circulation coins and collector coins, but it's very helpful for certain counterfeits, especially ancient, or not ancient, but older US dollars and sovereigns. And by the way, does anybody know how many mils does a 2 euro coin have? What? 2 euros, yes. Oh, I thought it was 252. Okay, yeah, but we can discuss it later. Yeah. Anyway, types of counterfeit gold coins. We have counterfeits with a significant gold content, believe it or not. So typical features are gold content between 450 and 930 per thousand. And we have a deviation in the minting quality, especially of the edge lettering, that's what we can spot. And we have a deviation in number of mils. Here are typical representatives we encounter here in Germany. For example, the 20 marks German Kaiserreich, Emperor Wilhelm II, very, very popular. And here you see the minting defects. Here and there, and yeah, a not nicely trimmed moustache. So this is typical for the 20 marks, for one specific counterfeit of the 20 mark German Kaiserreich. Another coin which is very popular in Germany is the 20 Swiss franc Vrenli, with these nice dots here. They don't belong to the original, it's a counterfeit. And the British sovereign has this defect, so we can easily detect it by having a closer look, the microscope on it. A typical representative also are the 50 Mexican peso. And if you look at the physical data, comparing the counterfeit to the genuine coin, looking at the weight, there's almost no difference. Looking at the density, very close to each other, the standard. So this means the gold content, not bad. Electric conductivity, everything in range, diameter and thickness. But if you look on it with a microscope, you detect minting defects. And these are typical for this class of counterfeit. And we know this counterfeit for many, many years. It first appeared in 1971. Here's another defect. Yeah, coming to the second class of counterfeits, they are made out of non-based gold material. This can be steel, zinc, copper, or copper-based alloys. And in new times, we encounter tungsten core. So why is tungsten so interesting? Tungsten has the density of 19.2 grams per cubic centimeter, whereas gold has 19.3 grams per cubic centimeter. So very close by each other. Normally they coat it with a thin layer of 0.03 millimeters gold, and they can be detected by various means such as weight and magnetism. I will jump through that foil. It's a representative. It's the 4 ducats. Looking at the technical data, there is nothing which fits with the genuine coin, though the counterfeit can be easily detected. And here the coin with a tungsten core. This is a bit more difficult. The weight is very close to each other. Weights are very close to each other. The density is very close, and standard of one side is tungsten, and the electric conductivity of the tungsten core is disturbed because tungsten has a slight magnetism. Diameter, thickness, and grooves are very similar. And I mentioned that tungsten has slight magnetism. This is a counterfeit Krügerrand coming with a magnet on it. You don't detect anything, even with a strong rare earth magnet. But putting the coin on the rim, you see it works. So this can be one way of detecting counterfeit gold coins with tungsten. In order to learn more about the tungsten core coins, I visited the Forensic Institute of the Federal Criminal Police in Germany. It's right across the River Rhine. They have all kinds of equipment you can think of. We made a micrograph of it, and we went even deeper into the details, and we found out that we have here tungsten grains embedded in a copper matrix. And we have a very thin gold layer and an intermediate copper layer, and then we have the tungsten core. So summarizing, these tungsten counterfeits, they have slight magnetic properties. The chemical composition varies between 90% tungsten and 10% copper. We have a gold layer consisting of gold and 4% copper and 1% aluminium. And the thickness of this layer is very thin, 10 microns or 35 microns. So this is the range in which the gold layer is. Coming to the conclusions, we've learned that counterfeit gold coins appear in different variations. For a thorough examination, I would highly recommend to use more than one method. And to increase the hurdle for the counterfeiters, it might be worthwhile to discuss the use of security features. And I know that some of the manufacturers, they already use very sophisticated features, but it should become a certain standard in the gold coin world.